Welcome back. So we have to evaluate the integral of e raised power z cosine of pi z within a unit circle z equals to 1. So solution. As usual, we start by finding the poles. So the poles of f of z, and in this case, f of z is given by e raised power z over cos of pi z, are the roots of taking the denominator and equating to 0, i.e. cos of pi z equals to 0. And you see, when you have a cos function, so cos theta is 0 if and only if this theta is the angle n pi over 2, where n is an integer. So this means pi z is 0, cos of pi z is 0 if and only if pi z is the same as n pi over 2. So which means z should be n over 2, where n is any integer. So that means it can be 0, plus or minus 1, plus or minus 2, plus or minus 3. So this is an integer excluding 0. So 0 is not part of this set. So I can say n is a member of z star to mean that I'm removing 0. So hence the function f of z given by e raised power z over cosine of pi z has simple poles at so when you put n for plus or minus 1, you get plus or minus a half. Put 3. Actually, the thing is that now when you're specifying these values, it's not just the non-zero real numbers, non-zero integers, but they are non-zero odd integers where n is plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 7, plus or minus 9, etc. So n having the same condition. So here n plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 7, plus or minus 9, etc. So they're not just all the integers, but all the integers. Then plus or minus 3 over 2, plus or minus 5 over 2, plus or minus 7 over 2, etc. Of which only plus or minus a half, z equals to plus or minus a half, lies within the unit circle. So then we calculate the residues at these poles. So residue at, let's start with the half, z equals to a half, will be given by limit as z approaches a half of z minus a half, you multiply by f of z. So this will be limit as z approaches a half of z minus a half. F of z is given by e raised power z divided by cosine of pi z. Now, if you try to use direct substitution, so numerator will be 0, denominator will also be 0. So then we apply the L'Hospital's rule. To work out this limit. So L'Hospital's rule requires us to differentiate the numerator differently and then denominator differently. So IE will have limit z approaches a half. So this by product rule, so we'll have derivative of this one is 1 times this, we have e raised power z, plus derivative of this one is e raised power z, so e raised power z times z minus a half divided by, when you differentiate across function, you get negative, so pi sine of pi z. So when you put a half, so this will be now e raised power a half plus e raised power half into a half minus a half divided by negative pi sine of a half of pi is the same as pi over 2. And you see pi over 2, sine of pi over 2 is 1. So this is given by e raised power half. All this other part goes to 0. This will go to 0 because of this bracket, divided by minus pi. And then, so that was the residue at z equals to a half. So residue at z equals to minus a half will be limit z approaches minus a half, z minus a half, so be z plus a half, times f of z, so which will be limit as z approaches minus a half, z plus a half, f of z is given by e raised power z over cosine of pi z. Also by direct substitution, we get 0. So we'll have the case of numerator is 0, denominator is 0. So we use L'Hospital's rule. So we'll have limit z approaches minus a half. So to differentiate the numerator, use product rule. So the derivative of this is 1. So e raised power z plus the derivative of this is e raised power z, z plus a half. Derivative of the denominator is negative pi sine of pi z. So when you put negative a half for z, so we'll have divided by negative pi sine of now negative pi over 2. Sine of negative pi over 2 is negative 1. Negative 1 times negative pi is positive pi. And this other part is 0. This other part will be 0 because of this bracket. So this residue will just be e raised to power negative half over now positive pi. So by residue theorem, the integral along C of e raised power z over cosine of pi z will be 2 pi I times residue of the function at minus a positive half we have 2 pi I. So the first residue was e raised to power a half over pi over minus pi plus this other one is negative e raised to power negative a half over positive pi, which you can write as 2 pi I LCM is pi, so I can factor out negative. So I'll have e raised to power a half plus e raised to power negative a half. So that's what we'll have. So now for me to factor out negative, then I have to include negative sign here. So I'm taking this negative out, so then for me to have the original expression not changing, I then need to have a negative sign at this point here. And you see, this can be written as divide, if I put here pi, then I am removing that. I don't have to put this one here. So that pi and pi cancels out. So then, next I'll get negative 2i into e raised to power half minus e raised to power negative a half as my solution. But you see, we can write this one as, I can force a 2 here. I can force a 2 at this point here. And then so make this one 4. So I'll not have changed the meaning of the equation. So I will have minus 4i into e raised to power half minus e raised to power negative a half divided by 2. And you see, when I have e raised to power theta minus e raised to power minus theta over 2 is the definition of hyperbolic sine of theta. So therefore, this is the same as minus 4i and then times hyperbolic sine. So our theta here is a half. So this is the solution to our given problem. Thank you.